Maintenance is the premier building service contractor in Michigan, serving commercial, residential, industrial, medical, educational facilities, pretty much any building with 4 walls and a roof. If you have a problem to solve or you need a quality service, we are that company. A few of our capabilities include enhanced cleaning, electrostatic spraying, janitorial and porter services, floor care, window cleaning, construction cleanup, maintenance and repair, general labor. As long as it's not illegal, immoral, or life-threatening, we can probably set you up with some labor to perform whatever task you might have at hand. But one thing that definitely separates us above all the rest is that we have one unique capability, and that is we actually have 40 truck-mounted carpet cleaning vans in service night and day here in southeastern Michigan. 40 truck-mounted vehicles. And we equip each of them with portable units, including fans and dehumidifiers. We operate out of 4 strategic locations: Detroit, Toledo, Ohio, Ferndale, and Ypsilanti. We're able to respond to any flood in 1 to 2 hours. We have a warehouse full of fans and dehumidifiers. In addition to that, we are the only company in Michigan and Ohio powered by hydrology, which is our proprietary electrolyzed water system. Safe enough to drink, yet more powerful than alkaline cleaners and chemicals, which are really all of your detergents. They sit on the alkaline part of the pH scale. Why use our hydrology system? Well, as I mentioned before, there's no harsh chemicals or soaps, which means it's safe for children, pets, and the environment. There's no residual soap left behind, which means your carpet stays cleaner longer. Your carpet's not crunchy when you walk on it after it dries. Spills don't reoccur and your carpet dries faster. The bottom line here is that if we maintain your carpet with our proprietary hydrology system, your carpet's gonna last longer, meaning you get a higher return on your investment. With all that said, I would now like to welcome you to Building Shutdowns and the Unintended Consequences, presented by Brian Tognetti and Leah Ruther from Weiss, Janie Elsner and Associates. Gosh, guys, I hope I didn't kill that.
No worries.
Close enough.
All right. A few housekeeping points I want to bring up. For those of you who have a real estate license and did not provide it during registration, please do contact the BOMA office. And as always, attendance is monitored. It is a requirement. Oh, I'm so sorry. You probably don't want to listen to my phone call. As always, this meeting is monitored, as it is a requirement from the CE marketplace. There's also a question and answer period at the end of the presentation, but if you do have questions during the presentation, please put them in the chat section. We do hope to see you back next Thursday for COVID-19 best practices for payroll and HR. As always, thank you to our mega education sponsors, Brown & Brown Detroit, Marble Life, Grout Masters, and of course, us, my team at Master Maintenance. From me to all of you, please make it a great day and stay safe. Now I'm happy to turn it over to Brian and Leah.
All right. Thank you, Lynn. Appreciate that. And thanks to all of you for joining during your lunch hour. We appreciate it. Quick background on myself, Leah Ruther. I'm a structural engineer with our Detroit office at Weiss, Janie Elsner, WJE. And with me speaking is Brian, and I'll let him introduce himself.
Hello, everyone. Thanks for joining us today. And I'm Brian Tognetti. I manage our WJE Michigan office. We're located at 13 Mile and Telegraph, Bingham Farms, and I am an architect. We have a staff of 21 of us, including myself and Leah. Leah is located on the west side of Michigan as well. So,
yep.
Thanks, Leah.
Yeah. So a brief outline, you'll see a number of case studies, and that's essentially how we're going to deliver our presentation today about building shutdowns and the unintended consequences. And obviously there is a play on COVID-19 and how that has affected buildings relative to shutdowns or low occupancy. But before I get too far, I'd like to give a little introduction on who we are and what we do. So WJE is a collection of engineers and architects. We specialize in assessment and solving problems for existing buildings and structures. We have extensive experience with failure-related projects, and and that this presentation is sort of a play on our experience. We have an outside perspective, and often we get involved after a failure has occurred, so we have that hindsight of what may have been done differently to prevent the failure, if possible, and how to move forward. So failures encompass a wide range of scope and cause, and they can be related to weather events such as hurricanes, tornadoes, heavy snowfall, wind, and they can also be related to maybe design flaws or installation flaws. But today we are actually exploring, on occasion, these failures are directly related to variations of building shutdowns or low occupancy. And so, we'll share common themes that we've extracted from our experiences getting involved after a failure has occurred, and maybe some lessons learned on how to potentially avoid a failure at maybe your facility that you frequent, that you manage, or perhaps you own. So first case study here, construction shutdown leads to basement blooms. So what happened? This was a residence I visited last fall. You can see it's sort of under construction, partially complete, and this was the state it was at for a duration of time, but I'll get into that. And they had organic growth or mold. They discovered mold in their basement on their sheetrock on their walls, and they called us in to figure out what was the source of water. How did the water get in, and obviously then promote the mold growth. And water infiltration in the basement. So what we discovered, and I had the opportunity to be there during a heavy rainfall, which told me a story that water was getting in at the base of the wall. And you can see there's a rather large area here and then some other smaller areas. And so then it was a matter of, okay, how does that correlate to the exterior? And therefore, I was able to get outside and take a walk around the facility, or the residence. And to give you a background on the as-built construction, there you see these cream colored walls here. That's in insulated concrete form. So essentially there's insulation on both sides, and they pour the concrete in between, and the form stays in place, and the exterior serves as the weather resistant barrier. Along with that, they had some traditionally wood framed with a zip system sheathing that has these taped joints, these black tape. And then also the black tape, the yellow arrow is showing the black tape around the perimeter of fenestrations. Their foundation wall was waterproofed with sort of an asphaltic membrane that was direct fastened to the ICF, the insulated concrete form. And what we, as we walked around, we noted there were several defects or aspects of incomplete construction. You can see the tape here had sort of pulled away, and that was skyward facing, as well as an overdriven fastener. There were splits in the foundation waterproofing. Again, sort of defects with that membrane. And you can see they moved on with construction at that point, had put trim and siding on and hadn't treated that yet. So whether they were planning to or not, that was the state of it when I was there. So along with that, you can see there's no downspouts, no gutters, nothing to help manage the water. And unfortunately, there was a valley here where water would collect and drop down, and it happened to align with a defect in that membrane, an opening, which correlated with the larger water infiltration I saw inside. So it was rather obvious at that point that that was our path for infiltration. There were defects on the outside, water could find those defects and get inside, or incomplete, again, incomplete construction. So from a timeline perspective, construction commenced in fall of 2019. It was halted in 2020 in March when we all experienced the shutdown in Michigan. At that time, the exterior walls and doors and windows were installed. However, the exterior envelope was sort of partially complete, essentially in the state you saw in those photos. And on top of that, there was no operational HVAC. Mold was discovered in August of 2020. And I know there was very infrequent activity at the site or not many people had visited the site in that time frame. So that's about 4 to 5 months the site was left in an unfinished state. And you can only imagine, we had several weather events, several rains that sort of contributed to water finding its way on the inside. So a takeaway, obviously, providing temporary protection of incomplete aspects of construction would have helped mitigate some of the active water infiltration we saw. So picking up, cleaning up some of those defects in that membrane, or maybe putting in some temporary downspouts, something to keep water away from the facade, and also grade, trying to keep grade so it drains away from the building. And then again, schedule regular visits. It's possible if they had been routinely visiting this site, they might have seen some of the water infiltration in the basement and then been able to jump outside and to actually take care of those before it got worse and before they got to the mold growth. And that 4 to 5 month time frame, it meant enough water got in, and temperatures and the conditions inside with the relative humidity just promoted the growth of mold, which may not have occurred if they had just continued on with construction. So again, that temporary protection would have, I think, helped them greatly. And kind of along those lines, sort of a sidebar, I just worked on a project a few months ago, and it was a re-roof project or a roof project. And I had noted that they didn't have great temporary protection around the perimeter of their roof, and didn't seem to change much. And several months later, we do some non-destructive testing to see how's the roof performing, and a majority of it was saturated, and we could kind of attribute it back to that lack of temporary protection. So simple steps could prevent, a failure such as this, or like the roof situation. So I'm going to pass it off to Brian here to let him jump in on his next case study.
All right. Well, thank you, Leah. Looks like, let me try this. There we go. All right. So in case study number 2, it's really going to focus on just the kind of the dangers of, or just precautions that we need to be aware of when we dial back our mechanicals. This one happened to be, turn into some frothy fun carpet. This is kind of a title there for the case study, but just dialing back mechanicals is something that we do often, and there's good reason to do it, but we just need to be very cautious when we do that. And this case study kind of highlights a little bit of that. So what happened? So what took place here? This project took place at a school. It was a good school, elementary school, gearing up in the summertime to open, and this happened the week before opening the school, as you might imagine. I mean, there's a lot of activity that's going on to prepare the school. Teachers were arriving that week before Labor Day, and when they arrived, there was like a fuzz discovered throughout the classroom wings and a lot of the floors within the walled classrooms. And what you're looking at is just an aerial photo of the school. The orange outlines kind of the hard walled classrooms that you might imagine around a central corridor or a central kind of media center open volume. Just a little view of what you might expect a nice elementary school to look like. And so it's important just to keep in mind, how compartmentalization of a building can affect airflow and those kinds of things as well. This project also had a few other things going on that were causing some consternation, like what caused this mold growth. The blue circles on the roof are indicating areas where there were active roof leaks. There were roof leaks that happened just before this discovery in those 2 locations shown. The other issues that were compounding, there's 2 other ones. One was a mechanical unit, rooftop mechanical unit, had a faulting to where it wasn't operating, and that it was about 2 weeks before this discovery. And so there was some concern, did that contribute to this? And then also there was a significant construction project going around the perimeter of the fascia and how the roof interfaces. So there was an aged roof condition. That's just one of the examples of just the roofing was being replaced. So just there was a lot of things that were kind of colliding at once, and folks just wanted to know what happened with this. So from a timeline perspective, July to August 8th. So from July to August 8th, there was a wet carpet cleaning process that occurred, and it was significant. And I mean, it's what you do during the summer. You kind of get it ready, and things were ramping up, and interviewed the the janitorial staff. But at the same time, there was a process with dialing back the mechanical systems on the evenings and the weekends. It's not unheard of at all, in fact, for a school system to do that. And then August 27th through 29th, that was a weekend, the holiday weekend, and it was also the dialing back procedure was done. And interestingly, on Friday, August 6th at 6 p.m. was kind of the departure of the janitorial staff that week before, after completing their preparations. There was no mold, at least recognized or present on any of the carpet areas. Not that anyone would be looking specifically for it, but generally that was not present. And then on August 29th, which is a Monday, that's when the carpet mold discovery occurred in the morning as the teachers arrived. And it was really just it was like a hazy white fuzz that was noticed. So looking back, reviewing the weather records and looking back for multiple years, because this was a process that it wasn't unique for this time frame, but the frothy fact is that for that weekend period, there were 48 hours from the evening on August 26th to the morning of August 29th, where the exterior conditions were at or above 80% relative humidity. It was just one of those really steamy, really humid late August weekends. And that's very important as we kind of take a look at how does the exterior conditions relate to the interior conditions, especially if we're dialing back mechanical systems. And there are some good resources available for us. And that's why I want to let you know, the EPA has some, but certainly ASHRAE has a number of precautions to keep in mind. And the reason is we really, really want to make sure that we don't have a surface condition inside the building that results in an 80% relative humidity at that surface or just above that surface for an extended period of time. As soon as we have the food source, in this case, moisture, soap residue, whatever else is in the carpet, and we have those conditions, and it doesn't take very long, we can get some blooming happening. And so and the other piece to keep in mind here is how your mechanicals are actually set up for your building. If dehumidification of your building is handled through the cooling capacity of your, mechanical system, and that's the only dehumidification you have, it's a much higher risk to be dialing that back because you really have no means to dehumidify. And even if we get fans in there and we start pushing air around, we're really just pushing wet, humid air around. So we're not getting a full drying effect. Watch out for those late Michigan summers. And again, just what we're talking about. We often think of in the design world as architects and engineers, we're in the north, as we kind of look across the United States, but we really have we've got a tough climate for about a solid month of our summers where we design our buildings completely opposite to what we want. The vapor retarders on the wrong side of the wall. We're mainly a heating season, and all of a sudden we flip for a month of where we're really an intense cooling season, and we can so just be cautious of that August time frame. And we're going to definitely want to limit interior moisture load from cleaning and other normal operations. So maybe there's another way we can approach the carpet situation. And obviously, if we're unsure on our current process and we want to make sure we avoid a problem, feel free to reach out to folks, and there's lots of us out there that can help. So with that, Leah, back to you.
I'll take that control. And one thing I do want to apologize. I understand my video is flickering a little bit. I tried to fix it beforehand, but no luck. So I apologize for that. So case number 3, green roof leads to roof collapse, and you can kind of surmise where we're headed here. But so we got called in about a roof collapse. They had asked us to figure out what happened and why did it happen. And a little backstory, there was really only one tenant, I think only one individual really using this facility, and I think he was using it to work on kitchen equipment. And this room here was, I think, only the room he was actively using. There was a lot of other spaces that were very obviously infrequent visited. And when we walked, sidebar, so he lets his building manager or building owner know, I think you have a roof leak. And obviously we knew it was a collapse, but we walk in and see, okay, there's a little water and whatnot, and then walk through this hallway here and turn the corner and see that. And so I think I would classify that as more than a roof leak, but in any case, that's the collapse that we saw. And if get your bearings, we're standing on the first floor looking south, and this is actually the second floor that we're looking at. So the roof had collapsed onto the second floor and took part of the second floor with it. So then, walking around the building, we get into the basement. There was obvious standing water in the basement that had promoted a lot of mold growth down here. So it was rather distasteful to spend time in the basement. And then moving upwards, we moved to the second floor, and this is the actual roof level now. So this is, I'm on the floor looking at the roof. And so obviously a smaller square of the facility had collapsed. And then just a couple more shots. So this is standing on the roof looking south at the collapsed area. Up close of the collapse. And then just another shot of some organic or mold growth inside. So why did that happen? And often when we get to these sites, we have to figure out, what does the framing look like? Is it a structural capacity failure? Was there a demand that exceeded the capacity of the structure? Trying to sort of navigate, create a link between the cause and the collapse. And we found some plants in the collapsed area. We also found a roof conductor, which is not always surprising, but it was a component to take note of. And then standing on the roof, I kind of hid this from the earlier pictures. You can see there's something funny going on over here. So there's your collapsed area. And then we noticed there was a green roof, I would call it, or some plant growth. And what you don't realize is there's a drain in here. And so we quickly understood, okay, this roof wasn't draining very well. And along with that, you can kind of gather a story from some other aspects of how the roof was retaining that water. So there's your collapse, there's your second drain. And these lines here tell me the water had been sitting for a while. So these are stain lines from water that had likely been ponded there for some time. And if from a code perspective, we permit water to be on a roof for about 48 hours until we expect it to dry or to drain off. So yeah, it gets out pretty far. And on the parapet, we could measure some stain lines up to about 5.5 inches. So if you can imagine, there at one given time, there might have been about 5.5 inches of ponded water on this roof. So it's very likely the roof was not designed for that amount of water on the roof. So another friend of ours is often Google Earth. They have a feature where you can sort of go back in time and see what it was and what it is now. So we were able to get back to 2006. You can see there was a black roof then, again in 2008. And then in 2009, we see it was re-roofed. And there's actually 2 drains. So the one that we saw with the plant growth is right here. This was part of the collapsed area right there. So there was a second drain. Likewise. So then 2011, you start to see some debris growing at these roof drains. 2012, similar story, a little wider or bigger. And 2014, obviously much bigger debris growth. So looking at it from a timeline perspective, 2008, there was a re-roof. 2009 to 2015, debris builds up at the roof drains, and then the collapse in 2015. So there's 8 years of debris and water accumulation on the roof, and which obviously led to the roof collapse. So a couple, and then here's a nice sort of global shot of, you can see the progression. And so again, this coupled with what we could see in the field, and obviously the roof conductor and the debris, the staining lines, told us a story that the roof drains had been clogged, and they'd likely been clogged for a long time, which permitted a large accumulation of water on the roof. So from a takeaway perspective, I think it's obvious. Routine walkthroughs. If the gentleman who had been using the site had either just walked the area, or the property owner had taken some more time to visit the site more frequently, or get on the roof and just clear the roof drains. It's a really common problem we see, where the roof drains just get clogged. It's natural over time. And so it's reasonable to try and remove that debris to avoid a failure such as this. And along those lines, addressing actual roof leaks in a timely manner, because roof leaks may be small when they start, but they can grow, or they can cause a bigger problem, or get, that water can get in places you don't want it to, and potentially actually cause damage to your structural members. And then, like I suggested, the keeping roof drains clear. And to that point, I was on a site a couple weeks ago, and for a whole different matter, and happened to look around on the roof and saw this. And I shot an email off to the building owner and said, hey, you might want to take a look at this and get this cleared out. That can be a problem. It can allow, again, ponded water, and it's best to take care of it now before it becomes a bigger problem. So that's again, it's not a hard thing to do, but it can lead to some significant failures.
One thing I'll add, Leah, just for everyone's benefit too, and I mean, there's two things I'd like to bring up. One is just from a contractual perspective, from building ownership to building management to obviously tenants. Let's make sure we've got some clear lines of who is responsible for what, particularly with the roofing, and just kind of maintaining that roof and the plumbing systems. And then the second piece is, National Roofing Contractors Association is really a go-to resource for all things roofing, and they do recommend biannual inspections. So typically you want to get up there before winter, and you want to get up there in the spring. So 2 times a year, just to make sure to avoid this. And a lot of very good, reputable roofers offer those kinds of services. So just wanted to state that. So
sure. Okay. Well, now Brian's got another case study for us.
Alrighty here. Let's see. There we go. Okay, so case study number 4. It's a combo because it involves pipe failures. So water pipe failures lead to 2 things. One, there's mold meniscus, where we'll talk about that example, and a steam supreme in the other example. Just kind of lumped all the pipe issues together. And before we get too far in here, I know there's a lot of water. There's a theme of water coming at us with this program, and that's important because, frankly, when we talk about buildings, there are 2 main things that are the biggest heartburn or cost or what have you, and it's water and fire. Those are the 2 main things that are leading to property costs. So as we talk about building shutdowns or vacant buildings or lack of occupancy, those 2 can cause a lot of harm very quickly. One quick example on that related to pipes, but it's not one of the case studies of my own house. I was at the house preparing for a deposition. Got our kiddos, launched off to school, what have you, and left the house at about 9 a.m. And deposition got done a little bit quicker than I thought, and it was near the house, so I just went back to the house to get back to the kids. I was back at the house at 3 o'clock in the afternoon, so a period of 6 hours elapsed. And somehow, at some point while I was gone, our 3/8-inch diameter water supply line, the cold line up in the upstairs master bathroom, just split. And so I had up to 6 hours of flowing cold water in the house. And I just couldn't believe what I saw when I walked in. It happened right above where I was preparing for the deposition earlier in the morning. but within those 6 hours, it led to it was almost $100,000 worth of damage, 75 some odd $1,000, affected the second floor, main floor, basement, and I just, you know, it pays to visit often, I guess I would say. It's tough to be away. So case study number 4, mold meniscus. So what happened? What are we talking about here? This involved a second home, just a nice residence in a rural part of Michigan, you know, quaint area. Not a residence that's visited very often, but this is just a little diagram of in the basement. Like kind of to walk us through what's happened. But basically, the homeowner visited the home in I want to say late fall, then arrived in the spring. Didn't use it during the winter, and arrived in the spring to find just water all over the basement and just some significant you know, moisture-related distress throughout the home. And they as they walked into the basement, you can kind of see the stairway as they went down into the basement. There was water flowing from the overhead piping, which is in the floor assembly. The diagram is just showing there's like 5 little red boxes. Those are just additional breaks or breaches in the cold and hot water supply lines that are just up in the floor assembly. You can just visualize your basement at home. That's pretty common to run it in there. So kind of going through, there's just a little view of what that particular first location was that they could see, and obviously they turned the water off right away, and we get involved to find out, well, what happened? Why did this take place? And it turns out that here's another little split in a PVC line that was there. You know, the thermostat's dialed back, you know, lower during the winter time. Which a lot of us do. It wasn't in a reckless manner. It was taken down to either 55 or 60 degrees. And but the other piece that was going for this plumbing system, as I started to look closer, and it's part of looking at and finding the other fittings, is the soldering job on this one was not very well done. A lot of the fit, I actually could remove a 90-degree elbow just with my hands up there, and that's, you know, there's just not a lot of solder in the fittings and the components. So this particular plumbing system at this house was even more susceptible to a freeze-related failure. And as we know, you know, water freezes, it expands, and instead of a more traditional breach of your copper piping, which would be a split of the pipe wall, we call them fish mouths because they actually literally look like a fish mouth, or the fracturing of a coupling. We were actually having components just slide out of their soldered position. There wasn't the more traditional failure mechanisms. That's why folks were a little more confused as to why this happened. But this was a freeze failure. Had some cold weather, some cold spots, and just you know, airflow down in the basement was obstructed with other, you know, vents were closed, those kinds of things tied in. But it led to the mold meniscus, which is something I never thought I would ever see ever in my lifetime. I know that a photo is poor here, but it's grainy, but there's a few other shots. I'm walking around, and as an architect, I never thought studying I would see something like that. What is on the ground here? So bridging from the floor to the wall is literally this like fibrous, organic thing. I mean, I remember just kind of poking it with my flashlight, and it would jiggle. So it's almost like a movie set, and it was just something I had never seen to the extent that happened here. This is after, you know, extraction of the water, but there wasn't a real good mitigation process at all that had taken place yet. So thought I would share that with you, the timeline like we talked. You know, homeowner had visited in November. We had a normal freezing temps over winter. Heat was turned down, and just maybe a couple more visits, just, you know, trying to stay on top, could have avoided it. May 10th was the discovery. And 6 months elapsed, you know, no visit, heat turned down, water left on. So that was the other piece. It'd be really good to turn the water off if that's how infrequent we would be visiting this house. A lot of times when we, you having been in the industry now and seeing some things, when we go anywhere for probably more than 3 days, turn the water off, and not only turn the water off, but drain the lines. It's pretty easy. Just open up a valve up at the top, open up the valve at the bottom, and just drain the lines. It's pretty quick little process before you hit the road. You can save yourself a lot of headache. So that's the mold meniscus. Let's talk a little bit about the Steam Supreme, which was something I kind of thought I'd seen it all, but I guess I hadn't yet. So what happened? Another residence here, also a second home in the area. In this case, this was a hot water supply line, just to the vanity upstairs. It's a nice little small floor plan, single family, 1-story with basement. And that's a view circled there of, once I arrived, I turned the water was off. I turned the hot water line on, and you can see that is the supply line leading up to the sink. And what I'm circling there are actually, it's water flow, dripping from that. And that's just with me just turning the water supply on a little bit. Because once this issue was discovered, homeowner turned off all the water, and now I was involved to try to figure out what the heck happened and what's going on. But just wanted to show you that. So what was interesting is when you open up that hot water supply line all the way, which is what all of our homes have on. That's why we have hot water instantly as we turn our faucets on. When you open it all the way, within 5 minutes, when I closed that bathroom, the water was vigorously spraying from that location that I had circled, and it was creating a steam, as you can imagine. And within 5 minutes, within that bathroom, I already had 100% relative humidity in that room in 5 minutes with the spray. And what was also important to note is that the spray was, I don't want to say small enough, but the amount of water it was using was not enough to overcome the supply of water that the hot water tank could feed. So this problem was just a constantly fed steam in this house while no one was there. And that really led to a few interesting things upon the discovery. And then this was just inside the home, like, oh my gosh, what am I looking at? And the fan in particular is something, it's like, wow, that's kind of a designer series. I didn't think we could actually create something like that. Back in the bedrooms, that is not a wallpaper. That is a pattern. That is just, this house was overtaken with steam and likely had a near 100% relative humidity condition for an extended period of time. And this was a summertime frame. And here is that timeline. So homeowner last visited in April, normal temps, as you might imagine, spring and summer, left the water on, turned the thermostat down to 60 degrees, but really didn't matter. This is a summer issue. And on July 7th, when he arrived, that's when he walked into what you just saw, which I just can't imagine his reaction there. But one steamy situation. So 3 months elapsed, no visit, water left on, and the breach in the hot water line was, the hot water tank could keep up with it. So, it had a lot of things going that led to this issue. So just something to kind of keep in mind. And from a takeaway on these pipe issues, there's two things. One, there's the mold discovery. And if we don't want to have kind of these babies brewing in our basements, if anybody knows that movie, Aliens, or Sigourney Weaver showing up. So consider the potential for localized cold spots when you turn down your heat. When we turn down our thermostats to 55 or 60 degrees, that's okay. And that's for the areas that are receiving the supplied air. But there may be pipes behind cabinets, pipes in walls, pipes in corners that are far removed from that supply that could very well be in a condition that is way below what your lowest thermostat setting is. So just keep that in mind. Consider turning off the water as you leave for prolonged periods of time. If you're going to go for longer, consider just draining the system. And we should try to just visit more regularly. So with that, Leah, why don't you bring us to the home stretch here?
Sure. So lessons learned, and we share these case studies, not just to scare you or anything, and obviously some of them are unavoidable. Accidents happen, like Brian, gone for 6 hours, regular day. You can't prevent all of them, but there are some tips and tricks to try and, amp up maybe the number of times you visit the sites, how you maintain your sites, perhaps some data logs or photographs, just to try and get a better handle on where your building is at, where are potential issues, and how to, avoid a failure such as that. I mean, I had a pipe fail in my basement and I was sitting upstairs, and it went on for a couple hours until my husband came home. So it happens to all of us, but again, there's just little tips and tricks to try and avoid that. And again, we get involved after the fact, usually after a failure, and we get the benefit of hindsight to know what could have been done differently. And then again, site activity relative to building operation, like Brian's school job, and then also being aware of weather implications relative to high humidity, high heats, or cold and pipes and frozen pipes. So, and again, relative to occupancy too. And again, given we've all been experiencing some buildings that just don't have a lot of people in them these days. So understanding that, and therefore maybe taking a couple extra steps to try and be more aware of how your building is functioning. So that's what we've got for today. If you have any questions, I believe there's a chat option or whatnot. We'd be happy to answer any of those.